Thank you everybody for coming. My name is Iqbal Khan. It's a beautiful day outside. I'm here from Tampa, so it's much nicer in Tampa than here. I was expecting much cooler weather than what we have here. So thank you for staying indoors. I am a technology evangelist at this company called Alagisoft. We are the makers of Encash. Just the next 1 or 2 minutes is going to be our marketing statement, and then we'll get to. So we have two products for the .NET space. One is our main flagship product called Encash, which is a distributed cache for .NET. That's the expertise that we have. We've been in this space for about 10 years, So we've been in this space for about 10 years, and that's how we've built expertise in this specific topic. We have another product called NOSDB, which is something that we launched late last year. It's an open source NoSQL database for .NET. It's like a MongoDB level features, but native .NET, and again, all open source. Encash is also open source, and so is NOSDB. Please do take a look at our products. Okay. So I would prefer to have a more interactive discussion. We're going to go through a combination of some architectural, conceptual discussion and some source code, so we can actually see how you would go about using a cache for your application. So let's get started. Let's get a few definitions out of the way. Number one is what is scalability? Scalability is not performance. So if your application performs fast with 5 users, it's not scalable unless you can have the same good performance under 5,000, 50,000, or 500,000 users. Of course, if your application does not perform fast with 5 users, then you would need to look at other aspects than what we're going to talk about. Linear scalability is more of a deployment architecture terminology. If your application is architected in such a way that you can add more servers to increment your capacity, your transaction capacity. By the way, when I use the word scalability, I'm mainly talking about transaction capacity. I'm not talking about a lot of data. So we're not talking about terabytes of data in terms of scalability. We're talking about, can you handle a lot of transactions, a lot of activity. So linear scalability means that you can grow your transaction capacity just by adding servers, and there are no bottlenecks. And that is what we want to achieve. Non-linear, of course, is not something that we want to achieve. This means that it doesn't matter how many servers you add, your performance is going to go down after a certain point. But there's some fundamental bottleneck in your application architecture or in your deployment that is preventing you from being able to scale. What type of applications need scalability? These are usually server type of applications, ASP.NET or ASP.NET Core now, web services, which are usually WCF, IoT backend, which are usually web services, although they don't have to be. Big data processing applications. These are generally done in Java, but if you were to do it in .NET, you would have the same issue as you do in Java. And any other server application that needs to process a lot of transactions. You could be, for example, you could be a bank or a financial services company with millions of customers. They're calling you to change address, maybe transfer funds, and at night you have to process all of this for either compliance or for other SLA reasons. So even though you have, those are more batch processing, back-end processing, those are your other server apps that would still need to be able to process that much information. And if they're not able to, then you're in a lot of trouble. If you have these applications, most likely they will need scalability. So let's now talk about where is this problem, where is the scalability problem that we're going to try to address. Scalability problem really is not in the application tier. Your application, all those that I talked about, generally are architected in a way that you can add more servers, and there's no problem at all. The problem is with your data storage. What I mean by that is where your application data resides. Your relational databases, this could be SQL Server, Oracle, MySQL. It's not any one specific vendor. It's the concept of relational databases by design cannot scale. Actually, they cannot scale also in terms of amount of data also. That's why NoSQL databases have become so popular. But especially on transaction side. And the same is if you have mainframe legacy data. Many applications have to access legacy data. So that's where the bottleneck occurs. And if you have that bottleneck, then it doesn't matter if this tier is scalable, you won't be able to scale. And NoSQL databases have become popular for exact this reason, that they provide scalability. And we also have a NoSQL database product. But a lot of the time they don't address the issue. They cannot address the issue because for a combination of technical and business reasons, you cannot use them. To use a NoSQL database, you have to put data in them and not in your relational database. Some data you can do, you can definitely put in the NoSQL database, but a lot of your traditional business data is going to stay in relational databases. So if you can't move your data to NoSQL databases, they're no good. So you have to solve this problem, keeping in mind that you're going to continue living with relational databases. Even if you put a NoSQL database in the mix, that is only a subset of the data. It's not usually a replacement of relational databases. And being a NoSQL database company, I'm being very honest with you. When we talk to our customers, we don't say stop using relational. That's never going to happen. We say use it as an augmentation of relational. So if you have to stay with relational, you have to solve that problem with that in the mix. And that's where a distributed cache comes into the picture. That's why we're having this conversation. A distributed cache, let me define that a little bit. A distributed cache is distributed. It lives on 2 or more servers here. It's a separate caching tier, logically speaking. Physically, it can be on the same box as the application, but logically, it's a separate caching tier. 2 or more servers, and a distributed cache usually forms a cluster. So it is usually a cluster of these TCP-based clusters, what's most common, and Encache definitely uses TCP for clustering. And this cluster means that all the resources, all these servers, the CPU, the memory, the network cards are all pooled together. And that's how this becomes scalable, because you can add more and more servers as you need to increase capacity. This is something that you can do here also, but you cannot do here. As I said, you can add a NoSQL database in the mix, but you need to have this in the picture. And as soon as you have this in the picture, you will need something like this in your mix. A distributed cache lives on inexpensive servers. These are not high-end database, typical web server type of configurations. Most of our customers have an 8-core box. It used to be a dual CPU. Now we just use the word 8 cores, and 64-bit with just lots of memory. And lots means 16 to 32 gig is pretty much the average per server that we see. We don't even recommend more than 64 gig on each box, because if you have more than 64 gig of memory, .NET requires garbage collection, which is the GC itself is a pretty time-consuming task, and it starts to become a bottleneck by itself. So it's better to have more servers than to have really high-end few, because even though the cache is distributed by design, now the bottleneck starts to become garbage collection. And we've learned this through a lot of painful experiences over the years. And we had customers who went up to 128 gig, and suddenly there was a lot of pressure on the CPU, so they had to bump their processing power quite a bit. and it started to look more and more like a database server. So then, we recommended that bring it down. You cache data that is residing in the database. And 80% of the time you will basically be going to the caching tier. 20% of the time you go to the database. Cache is in memory, super fast, much faster than any database, including NoSQL database, including faster than our own NoSQL database. And cache is at least an order of magnitude faster than any database because of the fact that databases have to go to the disk. But all the updates, of course, have to go to the actual database, so that's where the 20% comes, plus, of course, some of the reads. Now, if you do that, suddenly all the pressure is taken off of the database. Now it performs, your reads are much faster, and the updates are also much faster. So you're able to achieve that scalability, but you're also able, not only is the application scalable now, it's suddenly faster. Although the main reason for using a cache is not to improve performance, which is again kind of opposite to what people have traditionally thought. That cache is there to improve performance. That's in a standalone situation, yes, that is the case. Even the databases use in-memory caching. Our NOSDB also uses caching built in, but it's really for scalability, where you need to be able to. Because that's a problem that you cannot buy yourself out of. You cannot buy more expensive hardware to get scalability. You have to architect the application and use the right infrastructure or the right components as part of your architecture if you're going to have a scalable application. This on the Java side, this is called an in-memory data grid. On the .NET side, it is called a distributed cache. Another word for this is an in-memory NoSQL key value store. There are three different ways to look at it. This is not a NoSQL database. It is a NoSQL key value in-memory store because it does not do any persistence. It does not have a permanent store. So when you have a picture like this, architecturally, I want you to be convinced that you will now have an application that will never have bottlenecks if you architect your application to use this as part of your infrastructure. Any questions so far before I move to the more dev type of stuff?
I guess the devil's in the details. How do you know whether the cache is stale, or if you update something, how does the cache get updated?
Let me come to that. Good question. Okay, so let's say that we're convinced that we need to have a distributed cache as part of our application architecture. The next question that comes to mind is, how do you use it? Where do you use the cache? And what are the issues related to each type of use? So as a .NET developer, and again, my focus is .NET, but the same concepts apply to other applications too. The most common use case is application data caching. That's what I was talking about up until now, where you have a database and you just cache data here. So the goal is to not go to the database as frequently. And you get all the benefits that I talked about. As soon as you do that, there's a problem that occurs, which is what you just talked about. The data now exists in two places. One is the permanent master store, which is your database, where it always must, and the second is the cache. And in fact, within the cache, it exists in more than one place, and I'll talk about that too. So when the data exists in more than one place, what could go wrong? It could get out of sync. So if a distributed cache cannot handle that situation, you're forced to cache read-only data. In fact, most people, when they think about cache, the knee-jerk reaction is, it's only for read-only data. Because if I cache data that changes, what I'm calling transactional data, then it's going to go out of sync. And if, that classic problem of withdrawing $1 million twice from the same bank account, it comes here. If a cache does not address this problem, then you're limited to a very small subset, about 10 to 15% of the data is all you can cache. And that is not sufficient. So a good distributed cache must address this problem, and I'll talk about that. Second use case is if you have an ASP.NET application There are 3 different things that you can store in it. Of course, this is changing as new frameworks are coming. So the most common is ASP.NET Session State, which is there in both the ASP.NET Core and the traditional ASP framework. Sessions are something that by default you store either in prog or you store them in SQL Server. Both have scalability problems. SQL also has performance problems. Because relational databases were not designed for storing blobs, and sessions are stored as blobs. And secondly, the same reason that you'd want to cache application data and not go to the database, you don't want to keep sessions in the database either. So this is a very, very ideal use case for ASP.NET applications. That's the first thing most of our customers use when they, if you have an existing application and you want to incorporate distributed cache, the least effort required to incorporate it is sessions. Because ASP.NET Framework allows a third-party cache to plug in. There's no programming needed. You just make a change to the web.config. In fact, let me quickly show you that. I'll just jump back and forth. I think that's probably better. So, for example, I have this a small ASP.NET application, and I have a web.config here. And I'm going to, of course, use Encache as the example. But let's say to use Encache as the session state provider, you need to put this assemblies. So add assembly tag. So this assembly of Encache has implemented the ASP.NET Session State Provider interface. So that's how it is complying with the ASP.NET Framework spec to be a third-party cache. So that's the first thing that you do. And second, you change the namespace. Actually, you just use this tag. So you make sure the mode is custom. And the timeout is definitely not 1 minute. It should be 20. And I'll come back to this, the cache name. So in case of Encache, all caches are named. I'll come back to this. So that's all you do. And your application starts storing the session in a cache. And you immediately see a performance boost because it's in memory much faster than SQL. Not faster than in prog, but faster than SQL, but more scalable in both cases. And the second use case for ASP.NET is ViewState, and that is if you are not using the MVC framework, if it's still the legacy ASP.NET, you have a ViewState, which you may or may not know. A ViewState, for those of you who don't know, is an encrypted. It's an encrypted string that is sent by the web server to the browser, only to come back when there's a post back. So, and this could get to hundreds of kilobytes in size. Multiply that by millions of requests that your application has to process, and there are 2 bad things that are happening. One, it is consuming a lot of bandwidth, and bandwidth is not free. When you host your application, you have to pay for bandwidth. Second, the response time is slower because it's a much heavier payload. So if you could cache that on the server end, it would just eliminate all of that and make the application faster. Output cache is an ASP.NET framework which allows you to cache page output so that if the page output doesn't change, it will just take it from the last execution. So again, there it's better to plug in a distributed cache in a web farm than to keep separate copies of that output cache in each web server. What you want to do actually is make these web servers totally stateless. From a application management perspective, if they are stateless, you can do all the patches, all the bug fixes, any upgrades to your application are a lot more frequent than any upgrades to the cache in terms of software upgrades. So if there's no state being maintained here, you could drop any of that box from the web farm. The user won't even notice because all the state is being maintained here or in the database. And these are again not something that you touch that frequently. So again, cache that. Now, in case of ASP.NET specific caching, there's one good thing that all of these require no programming. So you just plug them in immediately without any effort. The only thing you do, of course, is some sanity testing. For example, ASP.NET Session State, if you plug it in and you were using in-proc sessions, you might discover that not all of your objects are serializable. And you didn't know, and suddenly your application will start throwing exceptions. So, I mean, it's that level of testing that you need to do. But now, there's another peculiar problem that has happened. Unlike this one where you had 2 copies of the data, now the data exists only in the cache. So when an in-memory store is your master store, what could go wrong?
Machine goes down.
Yeah, you know, if any server goes down, you lose data. And you don't want to lose any of this data, especially not the sessions. So a good distributed cache must address this, and this is usually done through replication, that the same data exists at least in 2 places. And if that does not happen, then please don't put any sessions in that cache. Unless you don't, it's not really, it doesn't matter if your users lose this session, which is not the case in most situations. The third use case is runtime data sharing through events. This is something that typically people did with message queues, which they have their own place, and a distributed cache is not here to replace them. But a distributed cache is much faster, more scalable, and if the messages or if the data sharing is being done in the same location, in the same data center, then you can use a distributed cache in a pub/sub manner. You can do that. There are also other types of events. You can show interest in certain items, say if this item changes, please notify me. Or in case of Encache, there's a feature called continuous query where you could also do a SQL statement and say select customers where customer.city equals New York. If this data set is ever updated, deleted, or if a new object is added, updated, or deleted, please notify me. So that type of monitoring that the application can do, and that's how the consumers can be a lot smarter about what is it that they want to be notified about. And the producers can keep on updating the cache. So that's the third use case that a lot of people don't know, but now it's becoming more and more obvious that a cache is a very, very good place to do this, because it's you're already using the cache for these 2 reasons, so why not put this in? And this is very simple to incorporate in your application. Any questions before I go into the details of these? So I'm going to first show you what a cache looks like, so that you can then we can put that into the context of everything that we're talking about. I will use Encache as the example. So I have a bunch of VMs in Azure. So I've got a demo 1, demo 2, and a demo client. Demo 1 and 2 are my cache server VMs. Demo client is the application server box, so that's the cache client. So I've got all of that. So I'm going to go and I'm logged in. Let's say I'm logged into the demo client. I'm going to go ahead and create a cache. So I'm going to use Encache Manager, which is a graphical tool. Actually, I have started there. I'll go ahead and say create a new clustered cache. In case of Encache, all caches are named. I'm not going to explain all the details, just so each cache is named. I will pick a topology of the cache. Topology is actually a storage and replication strategy. In case of Encache, let me just quickly jump into that a little bit and I'll come back. So a topology, in case of Encache, let's say there's a topology called partition replica. So these 2 are cache servers. Here, and each server has one partition. So let's say in case of Encache creates one partition for each server, and each server contains a replica of another server's partition. Each partition contains 1/n of the number of total buckets. In case of Encache, there's 1,000 buckets per cache. So let's say if it's a 2-node cluster, it's a 500 buckets each. If it's a 3-node cluster, let's do 1/3, 1/3, 1/3. Partition replica, the partitions are active, the replicas are not active, they're passive. So the client only talks to the partitions. And let's say if a client goes and updates an item here, the partition goes ahead and replicates it to the replica. And that replication by default is asynchronous, because to get true scalability, you need to go to this eventual consistency model. But in some cases, your data is very sensitive. We have a lot of financial services companies like banks that use Encash, and their data is actually money, so they can't do eventual consistency in that case. So there, you have to do synchronous replication, which means that the application waits until the data is updated both places. If a server goes down, let's say if you had a 3-node cluster and a server 3 went down, partition 3 is down, replica 3 will immediately become active. So that's how you get the high availability. And now, once it is active, it will now realize there are only 2 servers and there are 3 partitions, which is not how it should be. So it will merge itself with partition 1 and 2. And once that is done, then a replica for partition 2 will be created here. All of that, in case of Encash, is done at runtime without your application even realizing that that's happening. Similarly, you could have a 2-node cluster and add a 3rd server, and again, the whole map will change from here to here automatically. So that's what that choice meant. So I'm just going to pick partition replica as a topology. I'll keep the asynchronous replication. I'll pick my first server, which is demo 1, second server, which is demo 2. I'll take all the defaults. I'm going to specify, I'll say it's only 1 gig. I'm going to specify partition size. In your case, if you have a 16 gig machine, you should leave about 2 to 2.5 gig for the OS and other processes, and consume everything else for the cache. And whatever the memory that you have left, half of it should be active partition, half of it is for the replica. When you're doing your capacity planning, it's really important that you allocate enough memory that in case of sessions, these sessions have enough memory to stay. Otherwise, when the cache has used up all this memory, then the cache is considered full, and then only one of 2 things will happen. Either the cache will reject any new entries, or it will evict some of the existing entries. Encash provides you 3 algorithms. The most common is least recently used. So the Encash will immediately evict 5% of the cache when the cache is considered full. So now that I've created this, I'm going to go ahead and add a client node, which in this case is demo client. And I will go ahead and say start the cache. So when I'm starting the cache, a lot is happening behind the scenes. So a new cluster is being formed, a cluster membership is being formed. That is being propagated to the client so that the client knows what the cluster membership is, what the distribution map is. So once all of that is done, then everything is up. So now I'm going to say statistics. I'm going to see some perfmon. And I want to now quickly just run this tool called stress test tool, which quickly runs. It quickly tests the cache in your environment. So let's say that way you don't have to do any programming to do this. So this is how a cache looks like. You will install something like this. Let's say you install Encash. It takes only this much time to get a 2-node cluster with an application sort of configured. In your case, you'll have more than 1 client, of course. Most of our customers, the most common configuration is about 5 to 8 clients and 2 to 3 node cache cluster. And then, as you add more and more clients, you add more servers. So now that you have this cache running, now let's go back into our actual topics. So now everything that we do, you need to keep that in mind, how we had this name cache created. And I've shown you the ASP.NET specific session state already. So now let's go into the application data caching, which is the bulk of my talk today. So in case of an application data caching, there's an API that you have to program to, because ASP.NET Core now has an interface called iDistributed Cache, which you can call that API, and then behind the scenes you can plug in a third-party cache. On the Java side, they have a very powerful API as a standard called JCache. But on the .NET side, there's nothing. So in most cases, you will actually need to program the actual cache API itself. So, but the API is very straightforward. In case of Ncache, this looks very much like the ASP.NET Cache object, if you notice. So what you're doing basically is you do a cache.get, you get the object, you do cache.add, insert, remove, and there are also async versions of it. Async means don't wait for the cache to be updated, just return the control, and you can specify a callback in that case. Let me quickly show you what an application looks like. So I've got this very simple console application that uses Ncache. So the first thing you need to do is make sure that you reference the cache assemblies, which in case of Ncache are two. There's ncache.runtime, or ncache.web. And then you need to use the namespaces, which are again two in case of Ncache. Ncache.runtime and ncache.web.caching. And then at the beginning of your application, which in case of console is right there. In case of ASP.NET application, this is probably your global.asax. You need to connect to the cache. And this is your cache name comes in. Whatever you named your cache, that's what comes in here. And now that you have a cache handle, you can go ahead in the application, you can create your objects, and you can do cache.add. You specify a string-based key, and the key has to be unique. This is not a good key, by the way. Your key needs to be much more specific. And here's your object. This is how, and then later on you can do cache.get, and you can get your object from the cache. Now, this call that you made actually resulted, in case of Ncache. So when you did cache.add, it basically went from here. It went to your whichever partition that data was supposed to go into. So it did a cache.add there, and this partition then replicated that data to its replica. If that was an asynchronous replication, then only this partition was updated and the control came back. If you made an async call, then even this partition, you didn't even wait for the partition to be updated. But just that one cache.add call resulted in all this work being done. And similarly, when you do a cache.get, the client goes directly where the data is. So it uses the distribution map underneath to know where the data is and goes directly where and gets that. Let's say if you wanted item number 3, you would go and get it straight away from there. So this code behind the scenes, that's what's really happening.
So when it's written to the data store, what is just the cache? Sorry.
It's just the cache. Actually, I'll talk about that in a bit too.
So you automatically serialize and deserialize?
Yes, exactly. In fact, it's even more than that. So before the data is sent from here to here, the object has to be serialized. In case of Ncache keeps it in a serialized form in the cache. And when you do a cache.get, it comes back and then gets deserialized in the client itself. And by the time you get it, it's all deserialized. So the API looks very straightforward to you, but there's a lot of work being done underneath. Now, about application data caching, the biggest concern was that the data exists in two places, right? And if a cache does not address that concern, it's going to really limit its benefit. So how does a cache address that concern? Number one is called expiration, and there's the absolute expiration, which means expire this object, let's say 10 minutes from now. So you make an educated guess for every object in terms of how long is it safe to keep that object in the cache. And at the end of that time, the cache automatically removes that object. Let me show you how that looks like in the code. So in case of encache, if you look at the same cache.add call, the third argument is a datetime argument, which has the value of 1 minute from now. So it is basically saying to the cache, expire this object 1 minute from now. It doesn't matter whether you need it or not. After 1 minute, that object will be removed from the cache. Why? Because you don't feel comfortable keeping it in the cache longer than 1 minute. And why don't you feel comfortable? Because you think it's going to change in the database. It's not safe to keep it in the cache. There's another type of expiration called sliding expiration, which serves a totally different purpose. It is not for keeping the cache fresh, it's more for cleanup. So in case of sessions, for example, you use a sliding, underneath, Encache uses a sliding expiration, which says basically, you specify an interval, and say 10 minutes, 20 minutes, 5 minutes, you say, so if for that long, if nobody touches that object, Encache removes that item from the cache. So sliding expiration, although the name still is expiration, it serves a totally different purpose. It's the absolute expiration that you need for application data caching to keep the cache fresh. Almost every cache has the absolute expiration, including Redis. Everybody has it. But the problem with absolute expiration is that you're only making a guess. What if that guess is wrong and the data actually changes in the database? Then what happens? You have to come up with a mechanism. So, if you have the ability to synchronize the cache with the database, where you can tell the cache to monitor the database for changes for this very specific data set, whatever that is. Encache, for example, uses this ADO.NET SQL cache dependency feature, where if you use this feature, let me show you how it is used. If you use this feature, then Encache it monitors the database, and it asks the database to notify Encache when that data changes. So let's say I've got the SQL dependency example. So again, I'm doing the same cache.add. Here. So I'm doing the same cache.add. I've got a key. Now instead of having the object, I have a cache item, which is a structure which contains the actual object plus a few other things. So for example, it contains a SQL statement of a single row in the product table. Since I'm caching a product in a Northwind database, this SQL statement, Encache then uses, so there's a SQL cache dependency class in Encache, which is our own class, but behind the scenes, it then maps to the ADO.NET SQL cache dependency. Now, you're making this call on the actual, and so you're making the call here, and that call is coming to the cache servers, and the cache server now makes the ADO.NET call against your SQL server database, and now the cache server becomes a client of your database. And it tells the database, it says, please notify me if this data set changes. And SQL Server has the database notification mechanism, so does Oracle. At least against these two databases, you can use this feature. And SQL cache dependency allows you to essentially make sure that if you can't guess, you can still rest assured that your data is going to stay consistent with the database. Any questions on this?
So do you have any framework components that look like that one?
Yeah, so Encache also has a plugin for EF, EF6 and now EF Core also. Up until EF Core, before EF Core, and EF did not really have a pluggable architecture. So we had to implement a custom ADO.NET provider and cache SQL queries.
But SQL Core now does have that?
SQL Core is a much more flexible architecture, so now we're able to provide an L2 cache, which in case of, and Hibernate, which is something that it has existed for a long time, and Hibernate has had that architecture for a very long time, and Encache provided the L2 cache for Hibernate, and also for Hibernate for the Java client. But EF now has that EF core has that architecture. So in case of EF core, you don't have to do any so the benefit of EF core is that you don't have to make these calls. The downside is, of course, that it's a very small subset of the cache that you use in terms of the features, because all these other things, for example, the SQL dependency part is something that Ncache provides, and you can configure that through the config files. But there are also a lot of other features that I'll talk about that you need to use. Which, if you just go through a pluggable architecture, they have to go with the least common denominator approach. So their API, whatever they use, cannot use a lot of the sophisticated features because not all caches provide them. So, and they need to be flexible for everybody. Whereas if you want to benefit, for example, on the Java side, almost all caches have all these features that I'm talking about. On the .NET side, almost none of them have it, other than Ncache. So it's not really an Ncache thing. It's the fact that .NET is not as advanced or as mature as the Java community is in using these best practices. So it's becoming more and more. The fact that now .NET Core has gone through such a big change is a pretty good indication of how things are going to improve. But as of today, if you want to keep the cache synchronized with the database, expirations is not sufficient. You have to go beyond expiration. You have to synchronize the cache with the database. And if the database does not support notification, then you can go with a polling approach, which is something that Ncache has implemented. There's a third approach, which is that you can use a CLR stored procedure to directly add the data from the database to the cache. So it's like you're reversing the whole paradigm. Now the database is feeding the cache. So, for example, you have a trigger that can make the call. I'm going to speed up, otherwise I won't complete all the topics. So this is a very important feature without which you really can't benefit. And you can synchronize the cache against non-relational data sources also. For example, in case of Ncache, there's a custom dependency feature, which is your code that can make calls. Let's say your data source is a cloud, and it's a web method call every time to actually know what the data is. Then none of that works, and this custom dependency is something that works. So custom dependency is your code that lives on the cache and is called by the cache to check the data source. So once you achieve this goal, you can start to cache more and more data into it and really benefit.
You said DB dependency, because I'm working with a mainframe right now, where SQL dependency or Oracle dependency doesn't work anymore. So how often the polling should be? Because I'm working with production data with multiple million records, transactions going around in a minute. So how often? So how do you know? Like how often do you need to poll it?
The polling is a configurable interval, and it's your code that will be called. So you then determine in each poll how much data are you going to look at. Because in case of custom dependency, you're going to actually go and check against a specific key and see if that key was updated in your legacy mainframe or not.
So it's basically for each key I need to go poll it, like, okay, check this key, check this key.
In case of custom dependency, in case of DB dependency, it's not one key, it's the entire data set. And we have another feature in Ncache called data updater. There's a cache loader, it's a cache updater, which is another service where your code lives. So there's a feature called cache loader in Ncache, which I didn't actually mention all those features here, but there's a feature called cache loader, which is your code that can, when you start the cache, it can go and load the cache, preload the cache from your data source. So that could be your mainframe. But there's also a feature called cache updater, which automatically calls your code every configurable interval, and that code can then go and check the entire data source and look for any updates based on your custom logic. And whatever data is changed, or whatever new data has occurred, or whatever data was deleted, that's something that you can also update the cache with. So the cache stays synchronized with your data source. By default, these are called at about 15-second intervals. but it can be faster, it can be more frequent, or it can be less frequent. That depends on your needs. Did that answer your question?
I have more, but I'll ask you
We can talk about that.
offline.
So once you achieve that goal, you start to cache more and more data. Then the next thing is, okay, now you've got what other benefits can you achieve? The next most important thing is the read through, write through. What is read through, write through? It's again your code that sits on the cache server. So when you do a cache.get, that's it. Show you the code. So let's say a read through is your code that you implement. Kisven Cache, you implement this interface called iReadThrough provider. It has three methods. There's an init, which gets called when the cache is started. This goes when the cache stops. But the most important is this load. So load is called, it passes, so the cache calls you this method. Ncache calls this method and passes you a key. And based on that key, you go to your database and you fetch that item. So when you do that, now the net effect to the client, the application is every time you do a cache.get, the cache always has the data. Of course, if you don't want the read through to call, you can do that too. You can have specifics, but the cache always has the data. So that's one benefit. So you're consolidating your persistence layer in a common caching tier. So if you have multiple applications using the same caching tier, the application is becoming simpler because they don't have to keep the same persistence code. They just do a cache.get and they get the domain object or the entity object from the cache. So the cache is looking a lot more like an EF now in terms of the cache. The read through itself can be EF based code. The other thing that you can do with the read through is that you can combine this with expirations and database synchronization, so that when those two things happen, instead of removing that data from the cache, why not reload it? Because when you remove it, the application will have to reload it anyway the next time it wants it. And in many cases, that data may be very, very frequently used. So you really want to reload it back into the cache. So a read through not only consolidates your code, but also improves your performance because your database is not being hit. In many of the e-commerce situations, the same data might be accessed so frequently that as soon as you remove it from the cache, thousands of requests will now hit the database for the same data. And we've seen customers complain about that keeps happening so frequently because there are millions of data items. As each data item expires, the database gets hit. So overall, even after having the cache, they were seeing a lot of hits on the database. So the answer to that was reload instead of expire. So the reload means the data never leaves the cache, it just gets updated. So the database is never touched except by one database call that the cache makes. So the read through is super important in that way. The other is the write through, which works just like read through except it does the writing, and the write means it can be either add, update, or delete. Now the write has another feature. One benefit of the write through is the same as read through, which is consolidation of the code. The second benefit is called write behind. Database updates, just like database reads are not fast, database updates are also not fast. So if your data is not that sensitive, if it's not something that you have to wait for the database to be updated, you can just update the cache so that all the application instances have the same data now, and let the cache update the data to the database in an asynchronous fashion. And suddenly your application's performance improves because you're not waiting for the cache to be updated. So write behind has this added benefit, and it builds a queue. In case of Ncache, that queue is also replicated to multiple servers. But again, read through, write through is very important features. And this is also something that is your code that lives on the cache server. I want you to keep this in mind. All this cache loader, the updater, the custom dependency, the read through, write through, all that is server code that lives on it, which is something that, again, these features exist on the Java side also. So it's not just something that Ncache invented. But you will not get these features in any of the other .NET based caches. So once you have all of this, once you do this, now you're putting a lot of data in the cache. You're really starting to benefit. And if a cache is only key value access, it's not very, very friendly. So a cache must accommodate friendly ways of fetching data. So in case of Ncache, there's a lot of data grouping that you can do. You can do group and subgroup, tags and name tags. You can also search based on SQL or link. So you can do something like select customers whereas customer.city equals New York. And now suddenly a lot of your data sets, especially the reference data that you need to read over and over again with a more filtered way, you can fetch it straight from the cache. And now you have the benefit that data you don't have to get rid of it. One thing keep in mind, anytime you're doing a SQL search, the entire data set must exist in the cache, because this will not go to the database. So it will only search the cache. Let's say if you said, give me all the customers based in New York. If all the customers are not in the cache, if all the New York customers are not in the cache, the Ncache or any cache will not give you the correct data set back. So that's an important thing to keep in mind, that people often confuse that, well, if I search, I expect if it's not in the cache, we'll go and get it from the database. But the SQL queries are not the database SQL queries. These are cache's own queries. Now, a lot of data, you can keep the entire data set in the cache, especially reference data. And that's where you would use these. Or at least within the transactional data also, there's subsets that can be entirely kept in the cache. So that's how you do it. So by keeping all of that in mind, now you're starting to benefit from the cache. I'm going to skip this. I want to go into one more thing, which is this feature called client cache. One of the things that people are really shocked when they start to use a distributed cache is that especially if they're using an in-prop cache before, that's standalone, is that their performance actually drops. So many customers call us and say, you were saying this performance is going to increase, scalability will improve, our performance actually dropped. And the reason is because initially they only had a standalone cache. It was limited in size, but the cache was in object form. The objects were kept in your heap, on your heaps. And now they have to go to a cache cluster. There's a serialization, there's a network trip. It's much, much slower. So to fix that problem, many of the caches, again, I use the word many because all the Java side caches have it, the .NET side Ncache has it. They have this feature called client cache. Some people call it, on the Java side it's called mirror cache. This is the same standalone cache that you had previously, but same means similar. But this is now aware of the fact that it's part of this clustered cache. So whatever data it's keeping, it's keeping it synchronized with the cache cluster. So you can, and it just plugs in without you doing any programming. So with the help of a client cache, you can achieve that in-proc standalone cache performance, and it's really good for a lot of the data where you're doing a lot more reads than writes. You don't want to use this for something like sessions, because sessions you do one read and one write. So you have to be doing a lot more reads than writes to benefit. I'm going to try to speed up, but I think we're almost out of time. So architecturally, you need to see that cache is like the database now. It lives in your data center, your production environment, and if your application has a high availability need, then the cache must also be highly available. Otherwise, you'll have a problem. And the only way to do that is if the cache ensures that it is 100% uptime. So a good cache, in case of Ncache, it has a dynamic cache cluster. It's a peer-to-peer architecture. You can add or drop any server and everything is fine. Nothing stops. The cache does not stop. The application does not stop. So, we've talked about the partition and the topologies already. The replication has to be done intelligently. So in case of partition replica, it only makes one copy. So the data exists only in two places and not more than two, because every time you make copies, it costs more time or effort. It slows down things. There's also a feature called WAN replication. Many people have multiple data centers now. If you expect your database to be able to handle multiple data centers, why not the cache? Again, this is a feature most Java caches have it, and Cache has it too, but nobody else has it on that. Just quickly, one last thing, which is since on the .NET side, there are really only two options. One is Ncache, one is Redis. Redis actually is more from a Linux-based cache, but since Microsoft partnered with them on Azure, they have certainly become a lot more popular. So I wanted to give a fair comparison. By the way, if you just go to our website, and you go to the comparisons page, you can go to detailed feature by feature comparison based on their documentation and our documentation, and see all the stuff. And this is not we're not spinning this at all. And you can be a good judge of that yourself. It's just to make your job easier of comparing. But they're both open source. But Ncache is native .NET. For .NET people, it's your whole stack is .NET. Ncache allows you to have .NET code on the server side that you cannot do with Redis. If you're on Azure, Redis is available only as a cache as a service. Whereas we have intentionally not chosen that model. Because in cache as a service, the cache is a black box. So you don't have any of the server-side features that we just talked about. And with the VM model, you have total control. Most of our customers are high-end companies that really don't want to let go of their control. It's like SQL database versus SQL server. With Ncache, you will control your entire environment, and it's as you saw, it's pretty straightforward to do. But you get all of these server-side features with Ncache, which you don't with Redis because you don't have any access to it. So again, make up your own mind, but at the minimum, do use a distributed cache in your architecture. Make sure that it is ready to scale. That's the whole goal. Thank you very much, guys.